This conference will now be recorded.
Good morning, students. In the today's class, we are going to discuss the characteristics of water surface profiles in the open channels. Last class I explained in the open channels, depending upon the channel bottom slope and depending upon the location of the water surface profile in zone 1, zone 2, zone 3, we have different water surface profiles in open channels. For example, if you consider the critical slope channel, in the critical slope channel, we have two water surface profiles indicated as C1 and C3. In the mild slope channel, we have three water surface profiles indicated as M1, M2, M3. In steep slope channel, the water surface profiles are S1, S2, S3. In the horizontal slope channel, water surface profiles are H2, H3. And in the adverse slope channel, the water surface profiles are A2, A3. Already in the last class, I explained in those water surface profiles, some water surface profiles are rising in the direction of water flow. Rising means the depth of water flow in those water surface profiles increases in the direction of water flow. That is called rising water surface profiles. And some other water surface profiles are falling water surface profiles. Falling water surface profiles means the depth of water flow in that water surface profile decreases in the direction of water flow, in the direction of movement of water flow. So in open channels, some water surface profiles, for example, if you take the water surface profile M1 in the mild slope channel, the water surface profile M1 is a rising water surface profile. S1 is also rising water surface profile in steep slope channel, and also C1 rising water surface profile in the critical slope channel. And if I take M2 in the mild slope channel, M2 water surface profile is a falling water surface profile in the mild slope channel. Similarly S2, similarly H2, similarly A2, all are the falling water surface profiles. In open channels, the rising water surface profile is known as backwater curve. In open channels, the rising water surface profile is called backwater curve. The falling water surface profile is called drawdown curve. So like that, in open channels, either in the natural open channels or in artificial open channels, the water surface profiles in the open channels are classified as backwater curves and drawdown curves. Backwater curves means if the water surface profile is a rising water surface profile, it is called backwater curve. Drawdown curve means if the water surface profile is a falling water surface profile, it is called drawdown curve. We know that the water surface profile is a rising water surface profile if the slope of that water surface profile dy by dx is positive. If the slope of water surface profile dy by dx is positive, the water surface profile is a rising water surface profile. This is the dynamic equation of gradually varied flow. We discuss in unit 2 the derivation of this dy by dx. In the gradually varied flow, this dy by dx is equal to S0 minus Sf divided by 1 minus q square t by Ga cube. That is called dynamic equation of gradually varied flow. In that, dy by dx is the slope of the water surface profile with respect to channel bottom. If that slope dy by dx is positive, the water surface profile is a rising water surface profile in open channels. The rising water surface profile is called backwater curve. Whereas if the slope dy by dx of water surface profile is negative, we call that water surface profile as a falling water surface profile. In open channels, the falling water surface profile is called drawdown curve. So like that, in open channels. Please keep in mind, either the open channel is natural channel like rivers or the artificial channels. In open channels, the water surface profiles are either backwater curves or the drawdown curves. Now coming to this list of water surface profiles in open channels, the water surface profiles C1, C3, M1, M3, S1, S3, H3, A3. C1, C3, M1, M3, S1, S3, H3 and A3. These water surface profiles are rising water surface profiles, so they considered as backwater curves. And in the open channels, the water surface profiles M2, S2, H2, A2 are the falling water surface profiles. They are called as drawdown curves. Now, I am going to explain why some of the water surface profiles are rising and why some other water surface profiles are falling in the open channels. In order to study the nature of these water surface profiles, in order to study the nature of water surface profiles, we are using the dynamic equation of gradually varied flow in the wide rectangular channels. So please everyone remember, in unit 2 already I explained the dynamic equation of gradually varied flow in wide rectangular channel by using Chessy's formula, and also by using Manning's formula, we derived the dynamic equation of gradually varied flow in the wide rectangular channel. According to Chessy's formula, dy by dx is equal to S naught into 1 minus yn by y whole cube divided by 1 minus yc by y whole cube. That is the dynamic equation of gradually varied flow in the wide rectangular channel according to Chessy's equation. Similarly, according to Manning's equation, dy by dx is equal to S naught into 1 minus yn by y whole power 10 by 3, yn by y power 10 by 3 divided by 1 minus yc by y power 3. This is the dynamic equation of gradually varied flow in the wide rectangular channel according to Manning's equation. Now, by considering either the Chessy's equation or the Manning's equation, you can take any one. By considering either the Chessy's dynamic equation or the Manning's dynamic equation, we are going to discuss the different characteristics of water surface profiles in the open channels. So in this discussion, the characteristics of water surface profiles, we are going to consider any one equation, either the equation 1 of Chessy's or the equation 2 of Manning's. Both are same results. But for our understanding purpose, I am going to consider this Chessy's equation. dy by dx equal to S naught into 1 minus yn by y whole cube divided by 1 minus yc by y whole cube. I am going to use this equation to explain the characteristics of water surface profiles in the open channels. I will get the same results by using this equation 2 also. There is no difference at all. But for easy understanding purpose, in the today's class, I am going to take down this equation. This is the dynamic equation of gradually varied flow in the wide rectangular channel according to Chessy's. Please in the notes note down this equation first. Everyone in your notes note down this equation. This is the dynamic equation of gradually varied flow in the wide rectangular channel. We are using this equation to understand the characteristics of water surface profiles in the open channels. Check this right hand side. In this right hand side, S naught channel bottom slope, and in the right hand side, Yn normal depth of flow, Yc critical depth of flow. First of all, every student should know how to determine this Yn, Yc in the open channels. How to determine the critical depth in open channel? How to determine the normal depth in open channel? So first I am going to explain you the determination of Yc and determination of Yn in the open channels. So first understand that determination of Yc and Yn, then you can easily understand the characteristics of water surface profiles in open channels. Dear students, please check this slide on your cell phone screens. I am going to explain you the determination of critical depth in open channels, Yc. How to determine the critical depth in open channel. Now go through that derivation of Yc carefully. To explain that derivation of Yc critical depth, I consider an open channel of bottom width B having the discharge of water flow Q. So go through this derivation carefully. This is very important to understand the characteristics of water surface profiles in open channels. So to discuss that derivation of Yc critical depth, consider an open channel, rectangular, trapezoidal, or triangular, circular, whatever it may be. Consider an open channel of bottom width B. Let in that open channel the discharge of flow is Q. In that open channel of bottom width B, discharge of flow Q, that Yc is the critical depth of flow. In that open channel of bottom width B, discharge of flow Q, let Yc is the critical depth of flow. I am explaining this slowly because you have to note down these concepts. So please everyone in your notes note down this determination of Yc from this slide. So to discuss this determination of Yc, we consider a channel, open channel of bottom width B. Let in that open channel the discharge of water flow is Q. Now in that open channel, that may be artificial or natural, in that open channel, take Yc is the critical depth of flow in that open channel. Now in this discussion, this Q is called the total discharge of flow. Q is the total discharge of flow. B is the bottom width. Then Q by B, total discharge divided by bottom width B. Q by B is called the discharge of flow per unit width small q. So here the discharge of water flow per unit width Q is equal to small q is equal to total discharge divided by bottom width B. So by knowing this total discharge Q, by knowing this bottom width B, I can calculate this small q. Now by knowing this small q, what is this small q? Discharge per unit width in the open channel. By knowing this small q, I can calculate the critical depth of flow in the open channel. So in that open channel, the critical depth of flow Yc is equal to q square by z whole power 1 by 3. This is the equation to find out the critical depth of flow in the open channel. So to discuss this determination of critical depth Yc, we consider an open channel of bottom width B. Let in that open channel the discharge of flow is Q. Then in that open channel we assume Yc is the critical depth of flow in that open channel. Here Q is the total discharge of water flow, B is the bottom width. We call this Q by B ratio, total discharge divided by bottom width B, as the discharge of water flow per unit width small q. By knowing this small q, discharge of water flow per unit width, I can calculate the critical depth of flow in the open channel. Yc is equal to q square by z whole power 1 by 3. This is the equation to find out the critical depth of flow in the open channel. So by using this equation, we can determine the critical depth of flow in that open channel. Then the next one is how to determine the normal depth of flow in the open channel. Please everyone follow that determination of normal depth of flow Yn in the open channel. You know that at a normal depth Yn, the water flow in the open channel is uniform flow. I am going to explain this normal depth of water flow in the open channel by considering the wide rectangular channel. You can use this same procedure even for the other channels also. But for your easy understanding, I am going to explain this determination of normal depth Yn in the open channel by considering a wide rectangular channel. You know that at normal depth Yn, the water flow in the channel is uniform flow. Now coming to this determination of the normal depth Yn in the wide rectangular open channel. So to discuss this determination of normal depth Yn in the open channel, consider a wide rectangular channel of bottom width B. Let in that wide rectangular channel the discharge of flow is Q. We consider a wide rectangular channel of bottom width B. Discharge of water flow is Q. Assume that in that wide rectangular channel, Yn is the normal depth of flow. In that wide rectangular channel, take Yn is the normal depth of flow. We are going to discuss how to determine this Yn. We know that in the wide rectangular channel, I explained in the previous classes, in the wide rectangular channel at normal depth Yn, the width is B, depth of flow is Yn. So in the wide rectangular channel, the wetted area A is equal to B into Yn, width into depth Yn. We know that in the wide rectangular channel, bottom width B far greater than depth of flow Yn. Since B far greater than Yn, for the wide rectangular channel, the wetted perimeter P is equal to B. It is actually B plus 2Yn, but B is far greater than Yn. 2Yn can be neglected. So in the wide rectangular channel, the wetted perimeter P is equal to B. Then the hydraulic radius R in the wide rectangular channel, R is equal to A by P. Byn divided by B, so it is Yn. So to discuss the determination of normal depth Yn in the open channels, first we consider the wide rectangular channel of bottom width B having the discharge of water flow Q. In that wide rectangular channel, take Yn is the normal depth of flow. At Yn depth, at normal depth of flow Yn, the wetted area of wide rectangular channel A, B into Yn, the wetted perimeter P is B, and the hydraulic radius is Yn. You know that at normal depth Yn, the flow in the open channel is uniform flow. Since the flow in the open channel is uniform flow, to find out this discharge Q, apply the Chezy's equation. So according to Chezy's equation, you know that at normal depth Yn, the flow in the channel is uniform flow. Apply the Chezy's equation to find out the discharge Q in that wide rectangular channel. According to Chezy's equation, discharge Q is equal to Ca into root R into S naught, not Sf, because at normal depth the flow is uniform. If the flow is gradually varied flow, you take Sf in the Chezy's equation. But at normal depth Yn, the flow in the channel is uniform flow. So in the Chezy's equation, we consider the channel bottom slope S naught. So the discharge Q is equal to C, Chezy's constant, into A, wetted area, into root R, hydraulic radius, into S naught. We know that at normal depth Yn, wetted area A, B into Yn. At normal depth Yn, hydraulic radius R is equal to Yn. Now this Chezy's equation, discharge Q is equal to C into B into Yn into root Yn into S naught. Simplify this right hand side. It is Yn into Yn power half. So C into B into Yn power half into S naught power half. So Yn power 1, Yn power 1 by 2. 1 plus 1 by 2 is 3 by 2. So discharge Q is equal to C into B, Yn power 3 by 2 into S naught power half. Square this equation on both sides. Square this equation on both sides. So Q square is equal to right hand side C square into B square into Yn power 3 by 2 whole square, that is Yc cube, into S naught power half whole square S naught. So Q square is equal to C square B square Yn cube S naught. So Yn cube is equal to, from this equation, Yn cube is equal to Q square divided by C square B square S naught. So from this equation, the normal depth Yn in the wide rectangular channel, Yn is equal to Q square by C square B square S naught whole power 1 by 3. This is the equation in the open channels to find out this normal depth Yn. So I explained the determination of critical depth Yc in the open channels, the determination of normal depth Yn in the open channels. So by using the previous equation, Yc is equal to small q square by z whole power 1 by 3, we can find out the critical depth in the open channel, and by using this equation, Yn is equal to q square by C square B square S naught whole power 1 by 3, we can find out the normal depth in open channels. So by using these two equations, you can calculate the critical depth Yc, normal depth Yn in the open channels. If the given depth of flow Y, please everyone listen, if the given depth of flow Y is greater than the normal depth Yn, critical depth Yc, the water surface is in zone 1. If the given depth of flow Y is in between normal depth Yn, critical depth Yc, the water surface is in zone 2. If the given depth Y is less than the critical depth Yc, normal depth Yn, the water surface is in zone 3. So like that, in the open channels, by knowing that critical depth Yc, normal depth Yn, we can find out the location of the water surface in the open channel, either in zone 1, zone 2 or zone 3. Dear students, up to this determination of Yc and Yn, if anybody is having doubts, please discuss with me. Just now I explained the determination of critical depth, the determination of normal depth in open channels. If anybody is having doubts regarding that determination of Yn and Yc, please discuss with me. If anybody is having doubts regarding that determination of Yn and Yc, please discuss with me. Any doubts, students, regarding the determination of critical depth Yc, normal depth Yn in the open channels? Okay, now coming to, please everyone listen this carefully, coming to the determination of slope of water surface in zone 1, zone 2 and zone 3. This is very important. Please listen this carefully. I am going to explain you the determination of slope dy by dx in the zone 1, zone 2 and also zone 3. You know that in open channels, some water surface profiles are in zone 1, some water surface profiles are in zone 2, some water surface profiles are in zone 3. So you should know what is that slope dy by dx of water surface profile in zone 1, whether that slope is positive or negative. What is that dy by dx? Either positive or negative in zone 1. What is dy by dx in zone 2? What is dy by dx in zone 3? Dy by dx is called the slope of the water surface profile in open channel. Now, to discuss that slope dy by dx in zone 1, zone 2 and zone 3, I am going to consider the Chezy's dynamic equation of wide rectangular channel. So here, to discuss the slope of the water surface profile in zone 1, zone 2 and zone 3, we consider the dynamic equation of wide rectangular channel according to Chezy's equation. Please everyone note down this equation in the notes. According to Chezy's formula, the dynamic equation of gradually varied flow in wide rectangular channel is dy by dx is equal to s naught into 1 minus yn by y power 3 yn by y power cube whole divided by 1 minus yc by y power 3. This is the dynamic equation of gradually varied flow in wide rectangular channel according to Chezy's equation. Please focus on this right hand side. Dy by dx is the slope of the water surface profile. Check this right hand side, S naught channel bottom slope constant. On this right hand side, Yn normal depth of flow. Just now I explained the determination of this Yn. Yc critical depth of flow. I also explained the determination of Yc. And what is this Y in the right hand side? Y is the depth of water flow in the open channel. Please everyone focus on this Y. Depth of water flow. You know that in zone 1, this depth of water flow Y is greater than normal depth Yn and also critical depth Yc. That is zone 1. In zone 2, the depth of flow Y is in between normal depth Yn, critical depth Yc. In zone 3, depth of flow Y is less than normal depth Yn, critical depth Yc. So here, this slope dy by dx, either positive or negative, depending on this depth of flow Y. I am going to explain what is this dy by dx in zone 1. So please everyone understand this carefully and also note down in the notes. We are going to discuss what is this dy by dx, either positive or negative in zone 1. Coming to this zone 1 in the open channel, I explained number of times. In zone 1, the depth of flow Y is greater than Yn, and also in zone 1, depth of flow Y greater than Yc. This is the condition in zone 1. Depth of flow Y in zone 1 greater than normal depth Yn, and also depth of flow Y in zone 1 greater than critical depth Yc. Now check. If Y is greater than Yn, what happens to this ratio Yn by Y? So detailed, I explain these steps carefully. I explain these steps in detail for your understanding. Go through them carefully. If Y is greater than Yn, what happens to this ratio Yn by Y? So if Y is greater than Yn by Y less than 1. Because this Y is greater than Yn, this ratio Yn by Y is less than 1. Since Yn by Y less than 1, Yn by Y whole cube is also less than 1. So at zone 1, in zone 1, Y is greater than Yn. The depth of flow Y greater than normal depth Yn, then Yn by Y less than 1. So Yn by Y whole cube is also less than 1. Since yn by y whole cube is less than 1, 1 minus yn by y whole cube, this is less than 1. Yn by y whole cube is less than 1. So 1 minus yn by y whole cube is positive. Because this yn by y whole cube is less than 1, 1 minus yn by y whole cube is positive. So in the zone 1, if yn is greater than yn by y less than 1, yn by y whole cube is also less than 1. So 1 minus yn by y whole cube is positive. So this numerator in zone 1 is positive. 1 minus yn by y whole cube is positive. Now coming to this denominator in zone 1, we know that y is greater than yc. In zone 1, depth of flow y is greater than the critical depth yc. Since y is greater than yc, yc by y is also less than 1. Because this depth of flow y is greater than yc, yc by y less than 1. Since yc by y less than 1, yc by y whole cube is also less than 1. So check this carefully. Yc by y whole cube is also less than 1. Since yc by y whole cube is less than 1, 1 minus yc by y whole cube is positive. Because this yc by y whole cube is less than 1. 1 minus yc by y whole cube is also positive. So in this equation, the denominator is also positive. So in the zone 1, in this dynamic equation, the numerator is positive, 1 minus yn by y whole cube is positive, and the denominator 1 minus yc by y whole cube is also positive. Since both are positive, in zone 1, this slope dy by dx is positive slope. So in the zone 1, y is greater than yn and also y is greater than yc. If y is greater than yn, 1 minus yn by y whole cube is positive. If y is greater than yc, 1 minus yc by y whole cube is also positive. So the numerator is positive, the denominator is positive. So in the zone 1, dy by dx is positive. We know that when the slope is positive slope, if the water surface profile is having this positive slope, the water surface profile is a rising water surface profile. So in the zone 1, whatever the channel bottom slope may be, whether the channel bottom slope is mild slope, channel bottom slope is steep slope, channel bottom slope is critical slope, in all those channels in zone 1, you know that in mild slope we have zone 1, in steep slope we have zone 1, in critical slope also we have zone 1. In all those channels, mild slope channel, steep slope channel, critical slope channel, in zone 1, the slope dy by dx is positive. So the water surface profiles in zone 1 are the rising water surface profiles. Because the slope of water surface profile in zone 1 is positive. So all the water surface profiles in zone 1 are having this positive slope. So those water surface profiles in zone 1 are the rising water surface profiles. Dear students, if anybody is having doubts about this slope dy by dx in zone 1, please discuss with me. If you have doubts about that slope dy by dx in zone 1, y greater than yn and also y greater than yc, please discuss with me. In that slide, I explained in detail about that slope dy by dx in zone 1. If y is greater than yn by y less than 1, so yn by y whole cube is also less than 1. So 1 minus yn by y whole cube is positive. In zone 1, y greater than yc. So yc by y less than 1. So yc by y whole cube less than 1. So 1 minus yc by y cube positive. So in zone 1, the slope dy by dx is positive. Either the slope is mild slope, steep slope or critical slope. In zone 1, the slope dy by dx is positive. So all the water surface profiles in zone 1 are having that positive slope dy by dx. So all the water surface profiles in zone 1 are the rising water surface profiles. I explained in this unit 2, when the slope dy by dx is positive, the water surface profile is a rising water surface profile. So if we have doubts in this zone 1 dy by dx, please give me the response. Please discuss with me. Any doubts, students? Any doubts, students? Okay. Coming to the zone 2 calculation of dy by dx. This is very important. Please listen this carefully. Determination of dy by dx in zone 2. We know that in zone 2, the depth of flow y is in between normal depth and critical depth. That is very important place. In zone 2, the depth of flow y is in between normal depth and critical depth. That in between is very important. That in between indicates sometimes in zone 2, the depth of flow y is less than the normal depth, but it is greater than the critical depth. That is one condition in zone 2. In zone 2, we know that the depth of flow y is in between the normal depth yn and critical depth yc. That indicates in zone 2, the depth of flow y is less than the normal depth, but it is greater than the critical depth. Other possibility in zone 2. The zone 2 is having the other possibility that in zone 2, the depth of flow y is greater than normal depth, but the depth of flow y is less than the critical depth. So check these two conditions in zone 2. These two conditions indicates the depth of flow y is in between normal depth and critical depth. So in this zone 2, first condition, the depth of flow y less than the normal depth, but the depth of flow y greater than the critical depth. So here the depth of flow y is in between the normal depth and critical depth. It is in between the normal depth and critical depth. Now coming to the slope dy by dx calculation in zone 2. First, if y is less than yn, if the depth of flow y less than the normal depth yn, then yn by y ratio, because this y is less than yn by y greater than 1. Because this y is less than yn by y greater than 1. So yn by y whole cube is greater than 1. So 1 minus yn by y whole cube is negative. Because this yn by y whole cube is negative, greater than 1, yn by y whole cube is greater than 1, 1 minus yn by y whole cube is negative. Remember that dynamic equation. What is the dynamic equation? This is the dynamic equation. So in that dynamic equation in zone 2, this numerator is negative. In zone 2, y is less than yn. So yn by y greater than 1. So yn by y whole cube greater than 1. So 1 minus yn by y whole cube is negative. Once this numerator is negative, the slope is negative. Check this denominator also. In that zone 2, this depth of flow y greater than yc. So in this condition 1, the depth of flow y greater than yc. If y is greater than yc, yc by y less than 1. So yc by y whole cube less than 1. So 1 minus yc by y whole cube is positive. So in this zone 2, when y is less than yc and y is less than yn and y is greater than yc, the numerator in this dynamic equation is negative. 1 minus yn by y whole cube is negative, but 1 minus yc by y whole cube is positive. So all over this dy by dx is negative because this numerator is negative. That is one condition in zone 1, zone 2. The first condition in zone 2 is the depth of flow y less than yn, but the depth of flow y greater than yc. For this condition in zone 2, the numerator is negative, but the denominator is positive, so the slope dy by dx is negative. Because this numerator is negative, the slope dy by dx is negative. Then in zone 2, the second condition is depth of flow y greater than yn, but the depth of flow y less than yc. Here also the depth of flow is in between yc and yn. This is the second condition in zone 2. The depth of flow y is in between yc and yn. Now if y is greater than yn, if the depth of flow greater than normal depth yn by y less than 1, so yn by y whole cube less than 1, so 1 minus yn by y whole cube is positive. So this is numerator. In the slope dy by dx, this is numerator. 1 minus yn by y whole cube is positive. But if y is less than yc, yc by y greater than 1, because this depth of flow is less than the critical depth yc by y greater than 1, so yc by y whole cube is greater than 1, so 1 minus yc by y whole cube is negative. So here the denominator is negative, numerator is positive, but the denominator is negative, so in this condition also the slope dy by dx is negative. So in this zone 2, either for this first condition, here the depth of flow y is in between the normal depth and critical depth. In this condition, the slope dy by dx is negative. And in the second condition also, here also the depth of flow y is in between the critical depth and normal depth. For this condition also, the slope dy by dx is negative. So in zone 2, whatever the channel bottom slope may be, either the channel bottom slope is mild slope, steep slope. In critical slope, we don't have zone 2. The zone 2 is not existing in critical slope. So in the zone 2 is existing in mild slope, steep slope, horizontal slope, and also adverse slope. Whatever the channel bottom slope may be, in zone 2 of all those channels, in all the open channels in zone 2, the slope of water surface profile dy by dx is negative. If the slope is negative, the water surface profile is a falling water surface profile. So in the zone 2 of all the open channels, in zone 2, the slope of the water surface profile is negative slope. Once that slope is negative, the water surface profile in zone 2 is a falling water surface. Whereas in zone 1, the water surface profile slope is positive. So in zone 1, the water surface profile is a rising water surface profile. But in zone 2, the water surface profile slope is negative, dy by dx negative. So in zone 2, the water surface profile is a falling water surface profile. Now please go through this calculation in the zone 2. If anybody is having doubt in this zone 2 slope dy by dx, please discuss with me. In the determination of slope dy by dx in zone 2, please discuss with me. If any one of you is having doubts regarding that slope dy by dx in zone 2, please discuss with me. Any doubts, students? Any doubts about that zone 2 dy by dx slope calculation? Please interact with me. If you have doubt regarding that dy by dx, either in zone 1 or zone 2, please ask me that doubt. Because I am not giving this explanation in the running notes. I am not giving this explanation in the running notes. So please everyone understand this calculation from this class. I am not going to give this calculation in the notes. So everyone please go through this calculation in the PPT. If you have doubts, please ask me. Any doubts, students, regarding that dy by dx in zone 2? Please give me the response. Is my voice audible to you? Give me the response, please. Give me the response. Is my voice audible to you? Any doubts, students?
Yes, sir. Audible, sir. Clear, sir.
Any doubts?
No, sir. Everything clear.
Please mute your mics. Please mute your mics, please. Now coming to the calculation of slope dy by dx in zone 3. Please everyone go through that calculation of dy by dx in zone 3. We know that in open channels at zone 3, the depth of flow y is less than the normal depth yn, and also it is less than the critical depth yc. That is the zone 3 in open channels. Now go through that zone 3 slope calculation. So check this carefully. In zone 3 in open channels, the depth of flow is less than the normal depth yn, and also the depth of flow y is less than the critical depth yc. This is the condition in zone 3. Now check this zone 3 calculation carefully. If this depth of flow y is less than yn, so please everyone follow this carefully. If the depth of flow y is less than yn, yn by y greater than 1. Because this depth of flow y is less than yn by y is greater than 1. So yn by y whole cube is also greater than 1. Now 1 minus yn by y whole cube. Because this yn by y whole cube is greater than 1, 1 minus yn by y whole cube is negative for this zone 3. So in the zone 3, the depth of flow y less than yn, and also depth of flow y less than yc. If the depth of flow y less than yn by y is greater than 1, so yn by y whole cube is also greater than 1. So 1 minus yn by y whole cube is negative. You know that this is the numerator in the slope equation. In the dy by dx equation, this is the numerator. 1 minus yn by y whole cube is negative. Now coming to the second condition. If y is less than yc, if y is less than yc, yc by y is greater than 1. Because this depth y less than this yc critical depth, yc by y greater than 1. So yc by y whole cube is greater than 1. Therefore 1 minus yc by y whole cube is negative. Because this yc by y whole cube is greater than 1, 1 minus yc by y whole cube is negative. You know that this is the denominator in the dy by dx equation. In dy by dx equation, this is the denominator. So in zone 3, the numerator is negative and also the denominator is negative. So check this calculation carefully. In zone 3, you know that dy by dx is equal to s naught into 1 minus yn by y cube divided by 1 minus yc by y cube. In zone 3, numerator 1 minus yn by y cube is negative. Denominator 1 minus yc by y cube is negative. Since the numerator is negative, denominator is negative, these two will cancel. Once this negative is cancelled, all together the slope dy by dx in zone 3 becomes positive because of the cancellation of the negative in the numerator and the negative in the denominator. These two negatives in the right hand side cancel with each other. So in zone 3, the slope dy by dx is positive. Since in zone 3, the slope of the water surface profile dy by dx is positive. In zone 3, the water surface profile is a rising water surface profile. So this is the calculation of dy by dx in zone 3. In zone 3, y is less than yn. So yn by y greater than 1, yn by y whole cube greater than 1. So 1 minus yn by y whole cube is negative numerator. Similarly, in zone 3, yc is less than yc. So yc by y greater than 1. So yc by y whole cube greater than 1. So 1 minus yc by y whole cube is negative. This is the denominator. So in zone 3, the numerator is negative. The denominator is also negative. These two negatives will cancel with each other. So in zone 3, the slope dy by dx is positive. So in zone 3, the water surface profile is positive, dy by dx is positive. So in zone 3, either in the mild slope, steep slope, critical slope, or horizontal slope and adverse slope, all the channels are having this zone 3. All the channels, mild slope channel, adverse slope, steep slope channel, critical slope channel, horizontal slope channel, adverse slope channel, all the channels are having this zone 3. At zone 3, the slope dy by dx is positive. So the water surface profiles in zone 3 are the rising water surface profiles. So this is the slope dy by dx of the water surface profiles in zone 1, zone 2 and zone 3. At zone 1, the water surface profile slope dy by dx is positive. So the water surface profile in zone 1 is a rising water surface profile. In zone 2, the slope dy by dx is negative. So the water surface profile in zone 2 is a falling water surface profile. In zone 3, the slope dy by dx is positive. So the water surface profile in zone 3 is a rising water surface profile. So this is the discussion on the slope dy by dx of the water surface profile in zone 1, zone 2 and zone 3. Now after this discussion, I am going to explain the one more additional topic before going to discuss the characteristics of water surface profiles in open channels. Now please everyone in the notes note down this mathematical calculation. This is very important to understand the characteristics of water surface profiles in the open channels. So please everyone note down this mathematical calculation here. Here I am going to explain you this value of dy by dx. The value of dy by dx for different values of depth of flow y. So in this discussion, I am going to explain not for zone 1, zone 2, zone 3. That is over. In zone 1, dy by dx is positive. Zone 2, dy by dx is negative. Zone 3, dy by dx is positive. That we completed already. I am going to discuss with you what is this dy by dx value for different values of depth of flow y. So please everyone note down this mathematical calculation while I am explaining on the PPT. So first consider the dynamic equation of gradually varied flow according to Chezy's equation. We know that according to Chezy's equation, the dynamic equation of gradually varied flow, for wide rectangular channel, dy by dx is equal to S0 into 1 minus yn by y whole cube divided by 1 minus yc by y cube. Now we are going to discuss what is the slope dy by dx for different values of depth of flow y. That is very important to understand the characteristics of water surface profiles in open channels. So I am going to explain you this value of dy by dx for different values of the depth of flow y. First, if the depth of flow y is equal to yn. So if the depth of flow y is equal to normal depth yn, what is this dy by dx? So if y is equal to yn, the ratio yn by y is equal to 1, because the depth of flow is equal to yn by y is equal to 1. So yn by y whole cube is also equal to 1. So 1 minus yn by y whole cube is 0. Because yn by y whole cube is 1, 1 minus yn by y whole cube is also 0. So this right hand side numerator is 0. So 0 by something, whatever this value may be, 0 by something is 0. 0 into S0 is also 0. So dy by dx equal to 0. So if the depth of flow y is equal to yn, in that condition, the slope dy by dx equal to 0. Please note down this in the notes. I am going to explain that characteristics later. To understand that characteristics, you should know these values, very important. So if the depth of flow y is equal to yn, the slope dy by dx equal to 0. This is the calculation, first consideration. So if the depth of flow y is equal to yn by y equal to 1, yn by y whole cube is also equal to 1. So 1 minus yn by y whole cube is 0. So this dy by dx equal to 0. So at this condition, if the depth of flow y is equal to normal depth yn, the slope dy by dx equal to 0. The second condition, if the depth of flow y is equal to yc, this is the Chassis equation. If the depth of flow y is equal to yc, what happens to this slope dy by dx? So check this calculation carefully. If y is equal to yc by y equal to 1. So yc by y whole cube is also equal to 1. So 1 minus yc by y whole cube is 0. Because this yc by y whole cube is 1. So 1 minus yc by y whole cube is 0. So this denominator is 0. 1 minus yc by y whole cube is 0. You know that something by 0 is infinity. Whatever this value may be, not necessary. Whatever this value may be, but this 1 minus yc by y whole cube is 0. So something by 0 is infinity. Infinity into S0 is also infinity. So the slope dy by dx is infinity. So the slope dy by dx is infinity if the depth of flow y is equal to critical depth yc. So check this dy by dx carefully, dear students. First, if y is equal to yn, just I explained the depth of flow y. If y is equal to yn, so we discussed just now the first condition. This is the first condition. If y is equal to yn, what is the slope dy by dx is 0. Please note down in the notes. If y is equal to yn, dy by dx is 0. Second condition, if y is equal to yc, dy by dx is infinity. Third condition, if y is equal to 0, that is the channel bottom. At channel bottom, y is equal to 0. If this y is equal to 0, what is the slope dy by dx? If this y is equal to 0, something by 0 is infinity. We know that if this y is equal to 0, yn by 1, yn by y, yn may be any value, but the depth of flow y is 0. That is at channel bottom. At channel bottom, y is 0. So yn by 0 is infinity. So yn by y whole cube is also infinity. And 1 minus yn by y whole cube is also infinity. 1 minus infinity is also infinity. Similarly, the denominator yc by y, yc, whatever the value may be, y is 0. Something by 0 is infinity. Yc by whole cube, yc by y whole cube is also infinity. 1 minus yc by y whole cube is also infinity. So here dy by dx is equal to S0 into infinity by infinity. This is again infinity. Please don't confuse that. Infinity by infinity is 1. That is not valid in mathematics. Infinity by infinity is also infinity. So at y is equal to 0 also, the slope dy by dx is infinity. So please note down that slope dy by dx for these three conditions. What is the slope dy by dx? At y is equal to yn, 0. Whereas at y is equal to yc, the slope dy by dx is infinity. At y is equal to 0, the slope dy by dx is also infinity. So we discuss in this today's class the determination of critical depth yc, the determination of normal depth yn, the dy by dx value in zone 1, zone 2, zone 3. In zone 1, dy by dx positive. In zone 2, dy by dx negative. In zone 3, dy by dx positive. And also we discuss dy by dx for y is equal to yn, 0. dy by dx for y is equal to yc, infinity. dy by dx for y is equal to 0 is also infinity. With this knowledge in mind, we are going to discuss the characteristics of water surface profiles in open channels. Then please the fourth condition, the fourth condition, y is equal to infinity. So in this discussion, calculation of dy by dx, we discuss y is equal to yn and y is equal to yc, y is equal to 0, and the fourth one is when the depth of flow is infinity. So just consider that depth of flow is infinity. If that y is equal to infinity, what is the slope dy by dx? So check this calculation. If the depth of flow y is infinity, then yn by 1, yn by y. So here something by infinity. You know that something by infinity is 0. So here please don't confuse. Something by 0 is infinity. So in the third case, y is 0. So in the third case, y is 0. So in the third case, yn by y is infinity. Because something by 0 is infinity. But here y is infinity. Fourth condition. When y is equal to infinity, that yn by y is 0. Something by infinity is 0. So yn by y whole cube is also 0. So 1 minus yn by y cube is equal to 1 because this is 0. Similarly, yc by y is 0. yc divided by infinity is 0. Y is infinity. So yc by y whole cube is 0. 1 minus yc by y whole cube is 1. So for this fourth condition, if the depth of flow is infinity, this numerator is 1, the denominator is also 1. So for this fourth condition, the slope dy by dx is equal to S0. The slope dy by dx at the depth of flow infinity is equal to S0. So please note down these four conditions in the notes as condition 1, y is equal to yn, dy by dx is equal to 0. Second condition, y is equal to yc, dy by dx is equal to infinity. Third condition, y is equal to 0, dy by dx is infinity. Fourth condition, y is equal to infinity, dy by dx is equal to S0. These four are the slope dy by dx for different values of depth of flow y. So here we discussed the slope dy by dx in zone 1 positive, dy by dx in zone 2 negative, dy by dx in zone 3 positive, and also the depth dy by dx at y is equal to yn is 0. dy by dx at y is equal to yc is infinity. dy by dx at y is equal to 0 is infinity. dy by dx at y is equal to infinity is S0. So with this knowledge in the mind, tomorrow class I will explain the characteristics of water surface profiles. Why this M1 is a rising water curve, and what is this nature of M1 water surface profile in the mild slope channel. Why this M2 is a falling water surface. What is this nature of M2 on the upstream side and on the downstream side. And what is this, why this M3 is a rising curve. What is this nature of M3 on the upstream side and also on the downstream side. So we will discuss these characteristics of water surface profiles in all the open channels in the tomorrow class. So please go through this today's class notes. While attending the tomorrow class, please come with this complete knowledge. Then you can understand clearly the reason for this nature of water surface profiles in the different open channel bottom slopes. So with this, I am going to stop the today's class. If you have any doubts, please discuss with me. If you don't have doubts, please leave from my class and join the next class. If you have any doubts, please discuss with me. Any doubts, students? Please give me the response. Any doubts of this today's class? Any doubts of this today's class? Any one of you give me the response. Any doubts of this today's class? Okay. Thank you. Please leave the class. I am going to stop the today's class. Join the next class.